Just a perfectly ordinary domestic cassette, and
Yes.
presumably that's the same in principle as the proper big computer has, like James Bond films, has big tapes rolling backwards and forwards. It's the same sort of thing.
That's exactly the same. Well, in principle it's the same. That's running about 250 times the speed of that, and they can run up to 8,000 times the speed of that. Things in computers don't happen 10 times or twice as fast. It's always 100 times or 1,000 times as fast.
But for our purposes, this is perfectly good.
We have a program in there, and we can put it into the machine.
Well, let's do it. Right, so far so good. There's a perfectly ordinary domestic cassette recorder.
Exactly.
OK, connected to this. Now, what happens next?
Well, we have to load the program into the machine. So you type load.
LOAD.
Now we've got to give it the name of the program. So in this particular machine, we have to use quotation marks to give it the name. So quotation marks, and the name of the game is Wall. It's the old Wall game.
Right.
Now we must switch on the cassette.
Yes.
And then hit return. And that puts the control back to the computer. And now it's beginning to search.
Right. Now, presumably, as you said, this is a fairly slow and laborious way of doing it, and we could speed things up by using one of the floppy disks you were talking about earlier.
Yes, on a floppy, this is about 130 times the speed of that, and of course it costs correspondingly more.
So this takes minutes and that takes seconds?
Yeah, it'll take half a minute, so that would take being in flash, no time at all.
Right. Now, how do we know it's finished?
Well, we've got the symbol back here, and that shows the computer's waiting for you to do your next thing.
So that's in there?
That's it, so we can switch it off.
And presumably we can check, can we, that what was on there is in there now?
Happily, yes. All you have to do is to type out list and it'll tell you what's in it.
List, L-I-S-T?
L-I-S-T. Return. As you
Wow. OK, that's
and
the
that
program
is
that was.
exactly what it's read in from that cassette.
Right. Right. OK, well, we know it's in there. How do we play the game?
Just tell it to run.
Run. Nice, simple English words, I must say. And return, I suppose.
That's it. And you should be in the game. It worked.
Right. Wall game. Move the bat. Left with the Z key, right with the X key. Try to knock all the bricks out with the ball. Bricks to the further back score more points. You're allowed 3 balls. Large or small bat. Well, I'll have an L bat. As a beginner. Press any key to serve. Right. Nice multicoloured game, that. I see. Yes, right. I think I get the picture.
Oh, I hope you're better at tennis than you are at this.
It's so simple to play. OK, well, obviously it's not just for playing games. They're terrific fun, but there must be more to it than that.
I really hate to see computers just used for playing games. To my mind, it's kind of degrading when they could be used for much more serious purposes. And, of course, there are millions of uses for them, many of which we're going to look at in this series. For example, you can actually use this to communicate with much larger scale computers through telephone networks. You can use it to communicate with other people who own micros, and you could use it to communicate with databases.
Yeah.
And that's what I'm going to show you right now.
All right.
And we're going to access a database, and we do this by typing star Prestel. So it's star Prestel. Prestel. We're now dialing Prestel automatically through the ordinary telephone lines, and we can access enormous databases, everything from the current share price to weather forecasts and so on.
And key something or other to continue.
That's the old hash up there, which is a shift and a hash.
Old hash, is it? Wonderful.
What would you like to do?
Well, we thought about this before the programme started, and I decided I want to fly to Paris.
One ticket. Oh, what a shame. Well, there we go, travel. And number 2.
OK.
2. And Presto.
Presto, I've never heard of that airline, but I'll take a chance.
Oh, we don't want to book a real ticket on one of the others.
I see. Now, we're going to Paris, so presumably I put 1 in there, and if that's where the little flashing thing is, that's where it's going to come. All right, 1.
And a hash.
And a hash. Economy. 1. Hash. Get in the hang of this. Date of travel, the 11th of January.
That's 11:01.
Just like that.
Yep, that's it.
Well, here goes. I hope it works. Good afternoon.
Good afternoon.
Now, I hope you've got a seat for me on the 6:30 flight to Paris this evening.
Right, sir. Can I have your name, please?
Sal, S-E-R-L-E.
Yes, sir. The BA316 at 18:30. How would you like to pay?
By credit card.
The fare is £64.
Wonderful. Really well. Well, obviously Heathrow is computer land. And planes now fly with so many passengers over such colossal distances at such enormous speeds. Airlines depend now completely on computers, because the only way they can sell tickets reasonably cheaply is by having full planes. And the other luxury of this colossal computer network is that I can cancel at any time I feel like it, right up till 5 minutes before the flight closes. And anybody else in the country or in the world can have the same seat on the same plane. What's more, without computers, the chances are this ticket to Paris could cost as much as £1,000. But before we get carried away with enthusiasm for these miracles of technology, perhaps we should consider a more objective view. Author and journalist Rex Malik has been observing and writing about the computer world for more than 20 years. And where does he think it's leading us?
It's leading us to major change. Some would say as unprecedented change has occurred during the First Industrial Revolution. Now, if you're going to understand the nature of that change, you'd better understand something of the nature of the technology which fuels it. In this program, they've shown you the Cray 1, the Weather Center computer, a supercomputer. Yet, in comparison to what's to come, that isn't even the equivalent of a Model T Ford. The Japanese have just started a program to build a computer 100 times as powerful. That program, they say, will take about 10 years. Okay, so it slips, say 20. That means very simply that at the end of 20 years, almost everybody will have one, or access to one. Now why? Well, because it's going to be made out of microelectronics. And it's in the nature of microelectronics that 90% of your costs come up front, i.e. it costs you 90% of the total to build the first one. Thereafter, you can shell them out like peas. So everybody has one. That means that a 15-year-old at school today, by the time he's 35 to 45, is going to have almost unbelievable brain and memory power added to aid him in his work. And there's another question, what people are going to use it for. Well, in fact, you're going to find that most of the time that computer's going to sit there idle. It's going to be parked just like the cars parked at the curb. Sometimes it'll go to top speed, but very seldom. Now, the question now becomes, it's not that do computers have social consequences? It is, what are the social consequences of computers? What are the issues that are raised? And remember, we're talking about a computer of 100 times the most powerful computer on the planet, and yet it's essentially built out of the very same technology that Chris booked his holiday on.
A BBC publication entitled The Computer Book, which explains what computers can do and how they work, will be available from bookshops from this Friday, the price £6.75. And for details of the materials and equipment available, including the BBC microcomputer system and the linked NEC correspondence course in programming, please send a stamped addressed envelope at least 12 inches by 9 inches to Broadcasting Support Services, P.O. Box 7, London W3 6XJ.